Right, hello everyone, hello YouTube. So welcome back to our free CCNA series. So this will be day 15 and we're going to discuss extended ACL. So what is extended ACL? So if you remember, last time we've talked about ACL, right? And the problem with ACL or the limitation with ACL is you can only filter traffic based on the source IP. So with extended ACL, by the term itself, it's just basically extending the features of a standard ACL. So if before we can only filter traffic based on the source, so with extended ACL, we can now filter traffic based on the destination, based on the protocol itself. So you have control over the filter that you can implement on your router. Okay, so for today's topic, we're going to discuss, of course, configuring extended ACL. It just means that we're going to use the number 100 to 1999 and 2000 to 2006 99s. So if you remember, in standard ACL, we also define specific numbers when we configure the standard ACL, like 1 to 99. That's how we define that, okay, we're using the standard ACL. And also part of our discussion today, we're going to modify ACL. Let's say maybe we forget something and at the middle of the protocol, and then how are we going to modify it. And of course, a real life example, our lab would be based on real setup for, let's say, a specific server. What's really the extended ACL is used for. Okay, so let's start. So for extended ACL, so let's say this is our lab. This is our lab used for. This is the lab we use for the standard ACL. So if you're going to check this one, you can see that there's ready show access list to show all the ACL. We already have access list created on this router. So it's more mainly from the source itself. So right now, let's say we have this source user. Okay, let me check if we have restriction on this one. Let's say show access list. Okay, so we only have one access list, number 18, and it permits to the whole network of 2.0, which is not, we're not blocking anything at all. Okay, so right now, let's say this is let's just put this one. This is like a public website. Okay, let's say this is a public website. So most of the configuration for public website, we sometimes don't allow the ping of that website, and we just allow them to access the actual website itself. So why are we doing that? Why do administrator do that? Because you don't like to be vulnerable for certain attacks, for ping flood, or anything that might cause disruption to the server itself. So that's the reason that pinging sometimes is disabled for certain server. So like for example, for this one, we ping the 192.168.1.11. So we should ping. This should be pingable, right? Let's see. Okay, so as you can see, ICMP is allowed, and the main purpose of the server would be, of course, the website itself. But since this is a simulation, so of course we're just going to see the default packet tracer website. Okay, so this might be changed. This might be a critical public website, but the thing is, it's accessible for both ICMP and also both for HTTPS traffic, which is 443, right? So our goal for today, of course, we're going to use extended ACL, and let's try to replicate that kind of setup. Let's say we would like to block all the ICMP traffic from the website itself, but we still need to make sure that it's still up for production. So it means that the HTTPS HTTPS should be still accessible even after we block the ACMP. Okay, so let's configure that. So configure terminal. So we're going to focus on the number itself. So IP access list, and if you question mark, you can see if you can see what are the options. So of course we're going to use extended, then question mark again. You can see you can either use the word, but for this topic we're just going to apply a number ACL, let's say 118, which is part of the range for extended ACL. Okay, now we're inside the extended ACL. If you put question mark here, you either can put sequence number or directly go with the deny or permit, or with the rules itself. Okay, so for CCNA we're just going to focus on the deny and permit, and also the sequence number. So by default, even if you're not going to write sequence number, there would be a default sequence number for this one. Okay, so let's say we'd like to allow traffic for, we will block ICMP, right? So this will be the source, this will be the destination, and the out packet would going to be gig 00 for this one. Okay, so first let's do the deny. So deny, then question mark. As you can see, these are all the protocols available. So for now, we're just going to focus on ICMP, TCP, and UDP, because those are the common protocols that we've discussed. But if you check, you can also see that, oh, okay, you can block EAGRP protocol here. You can also block OSPF protocol for the routers or using ACL. So deny ICMP. So if you put question mark, you can see that it will ask you for the source itself. So for this example, I'm just going to be very specific. Let's say host means we're creating a restriction for a single device, and the IP itself, so 192.168.2.2, and then another host would be the destination, so that's going to be the public website 168.1.11, and question mark. As you can see, ICMP has many protocols or maybe sub protocols in it, and we're just focused on the ping itself. So we're going to put restriction on the actual ping. Okay, right, so exit show access list. So as you can see, we have deny ACMP 2.0 echo. So let's try to ping it now. Oh, I forgot to add it on the interface itself. So if you show run, you see 00 out. So we did not add the access group yet. So this is still the standard access group. So configure terminal interface gig 00, IP access group 1118, and it's going to be an outbound traffic. Okay, let's try it again. Okay, so as you can see, we apply the traffic for outbound interface, and then right now it's already blocking the ICMP traffic. Now let's check if the HTTPS will still work after this, because we only blocked the ICMP, right? And let's see, 192.168.1.11. Wait, it's not loading. Okay, it's not loading. Okay, so it's request timeout. So why is that? Because if you remember, in ACL there's rule, like a hidden rule below it, that it will deny all the traffic for that ACL. So if you're going to show access these, you can see it's 4 matches, but below it there is like deny all. So what you're going to do, so we have to modify the ACL. So configure terminal IP access list extended 118, and then you have to permit IP any. Okay, so show access list. You can see we permit the IP. Let's see now. So as you can see, we need to define the permit IP any, which means that we're going to allow all traffic aside from the ICMP itself. So that's also how you modify. Let's say you'd like to put some rules in the middle, like you can go to this one and then IP access lease 118. Let's say you forget some extended 118 and you forget something, so that's the time that you define a number in the middle, like maybe permit. Let's say you'd like to add TCP, source address any, destination any, and then equals, let's say, port number for www. It's like, or 443 for HTTPS. Exit show access keys. So yeah, so you can also do that. So that's how you modify. Let's say if you forget something in the middle of the access list, you can just add the sequence number so that you don't have to delete it all. As you can see, okay, so as you can see, we already have updated access list on our setup. So that's how you modify. Let's say you forget something and you need to change, you need to add it in the middle. So remember, access list, it's sorting from top to bottom. So once it hit that specific rule, if it's permit or if it's deny, that will either block the traffic or will allow the traffic right away. Okay, so that's how we do the extended ACL. It's very simple, and you just have to be familiarized with how you create your restriction. And for example, we just specifically block the ICMP but allow all the traffic because we're saying, okay, this would be a public website. Okay, so that's our quick lecture for today. So I hope you guys learned something, and see you again next week for our free CCNA series. Okay, thank you guys. Goodbye.